Okay, so chapter 6, directional control. Hopefully by the time we get done with this chapter, we'll be able to identify the different types of check valves, identify different parts of a directional control valve and schematic diagrams, identify the different directional control valve designs, describe 2 or 3 position, 2, 3, and 4-way directional control valves, identify the 4 center positions used in 3-position, 4-way directional control valves, describe directional control valve mounting methods, identify the different types of directional control valve actuators, identify the main types of logic valves, identify the different types of control valve actuators, identify the main types of logic valves, explain hydraulic valve operation and safety. Check valve is just a valve that allows fluid flow in one direction, not the other. Pretty simple. 2 types, direct acting and pilot operated. Pilot operated is typically referred to as a POC, pilot operated check. We use them a lot over at CPS on hydraulic lifts. Check valve is always closed in both directions, doesn't allow the lift to move at all until you give it a pilot signal that opens up the check valve, and then you can control where the lift goes. Direct acting is just spring set. I like that. Got a spring on it that pushes the poppet into the valve seat. Doesn't matter how hard you push on it, you can't get any fluid to go that direction. Schematic symbol shows a ball into a arrowhead.
Kind of like a diode in electronics.
That's exactly what it is. Well, you can see, no matter how hard you push on that, you're not going to be able to shove that ball through that triangle or arrowhead, whatever. Coming back the other direction, the ball just pushes out of the way and you move on the line. Notice though that there is no spring symbol on there. There is such thing as a gravity operated check also. Those are typically pilot operated. There'll be no other way to open it up. Pilot operated check is a check that operates with a pilot line that allows or stops flow in both directions when activated. Pilot operated check valves are mainly used in hydraulic systems and can be piloted to open or pilot to close. Notice it's got the dashed line indicates pilot. You guys remember that from a couple of weeks ago?
When the check receives the pilot signal, it opens up the valves and then you move on to live.
Mm-hmm. For that particular one, yes. Spring is going to push it closed. Pilot signal is going to open it up. That's pilot to open. Pilot to close. Notice that the pilot line's on the other side. It's also got a spring in it. So it's already got a spring in it to close it. Why would you want the pilot line back closed? Right to the back, if anybody else have What? What do you say? No. Matthew?
Pause would be, what would would be when it gets signal or when the spraying closes the check valve where the string is in the seat and stops the fluid flow.
Okay, but why you need a pilot to close on one's already got spring in it?
The other one would be there to close it when the spring doesn't closes it.
You're really, really close. The spring is going to want to close it anyway. But if you put the pilot signal on it, no matter how much pressure you put here or here, it's not going to allow it to move. So this is going to be pressurized. More surface area here than you have here. Guess which one's going to win? F equals PA.
So the pilot line allows you to close the whole valve as opposed to just a directional. With just the spring, if you have inlet on the right side, it'll push the spring up and continue through.
Mm-hmm.
Okay.
You hit it with that pilot signal, no
Nothing
matter how much pressure you put there. Directional control, that happens to be a hand operated. Anybody want to take a stab on how that works? Ready?
On the hand thing, when you push it in one direction, it pushes the spring back, which changes the direction one way. When you pull it back, it changes the direction of the fluid flow a different way. Like on that schematic right there, when you have it pull back, that's when it will crush the crushing cylinder is going to be activated. When you push it forward, then the bend cylinder is activated.
Pull on it, let you pivot, and pull the spool this way. It's going to open this port up and allow port A to be connected to the reservoir fluid. So any fluid pressure that's in here is going to go back to your reservoir. At the same time, it's going to allow the pump port to connect here, move the cylinder the opposite direction. Let go of it, things get into a resting state, push on it, and goes the opposite direction.
Release.
It'll move that way. It'll actually block this pressure port. Much easier to see it like that. The position boxes. In the deactivated state, in this particular case, that is default path. Okay. Spring right there tells you it's going to push it in this direction. So this is your default. When you actuate it, instead of them being crossed, they're straight through. So one way, pressure goes out this port, comes back on that one, and then the other way, pressure goes out that port. back through that one. Identifying different parts of a schematic, position boxes, valve ports, internal arrows, spool actuator symbols, and directional control valve design name. So, two-way, either open or closed. What would be known as a two position, 2 ports. Okay. This position or that one, or the other. Three-way, known as a 3-2, 3-port, 2 position. 1, 2, 3. Anytime you see a T like this, tells you that port is blocked. So in position 1, spring return, just going to push it that way. I'm going to open up your A port to tank. Pump's going to be closed off, and then in the other position, pump will go through port A and tank port will be blocked off. That's a 4-3, 4-port, 3 position. Notice that the center position, all the ports are blocked. What is known as an APB center. All ports blocked center. Okay. APB valves are when you push it one direction or the other, it moves, and then when you release it, goes back to center position, it holds it there. It's like puts a check valve on all 4 lines, so nothing can move. Okay. Otherwise, they just crisscross. So one direction cylinder extends, other direction cylinder retracts. Okay. And spring on both ends means it's always going to default that center position. So the springs will move the spool to the center position when you're not applying an actuation force to it. That's internal workings of a 2-position and 3 positions. So the position boxes in the default position, we know it's default because of this spring. We have pressure going to the pressure port on this valve, but it's blocked so it doesn't do anything. And the cylinder is allowed to go straight back to tank. Okay. This in here tells you that it is a single acting cylinder. There's only one port to apply pressure to. The other way is spring return. Okay. So we should do the next way. So when you actuate it, it's going to go straight through to the cylinder, extend it, and since it's a spring return, there's no return path, so there's no fluid on that side. Oh, let me reach up there to zoom. Oh, what's wrong with me? It's nuts, I suppose. Okay, the box with the slash in it means it's solenoid operated. Okay. Spring. So it's solenoid operated both directions, the spring return to center. APB center, all ports blocked. 3-position 4-way. Be a 3-4. 3-position 4-port. Normal positions, normally open valve is a valve that allows fluid flow from the pump port to the actuator port in the spring actuated or normal position, the default position. A normally closed valve does not allow fluid flow from the pump port to the actuator port in its default position, which is exactly backwards of normally open, normally closed, and when we talk about electricity. Normally open switch will not allow current to flow, and normally closed switch will. We're talking about fluid power, a normally closed valve does not allow fluid to flow, normally open does. Okay. Control valve designs, 2-position 2-way, 2-position 3-way, 2-position 4-way, 3-position 4-way. Actually also have 5-2 and 5-3 valves where you have 5 ports instead of only 4. The port number 1 is always the pressure port. 2 and 4 are the outputs, and then 3 and 5 are the exhaust for the ports 2 and 4. If you're talking about a 5-port valve, it is always pneumatic because you don't want your hydraulic fluid pouring out on the floor. It has to have a path back to the reservoir. There's a bunch of 2-position 2-way control. So solenoid actuated, spring return, normally closed. 3-position 4-port. All ports block center, spring return, both directions, manually operated. What that is actually not a handle to operate with. It physically looks like that. Looks a whole lot more like the thing that's actually out there than the solenoid does on these. And you look at that and go, well, that looks like solenoid. Not so much, but you can look at that and go, hey, that looks like a handle. That's because it's a handle. So, just out of curiosity, how you reckon that's gonna work? Just system 1, 2, or 3, because they're all identical. Matthew?
I see that in system 3, you have the main actuator that controls the direction of the load, the cylinder load, and you also have the solenoid that controls whether or not there will be flow to the second directional control in system 3 for the load. So when solenoid allows flow through it, which pushes the directional control from a stress position to an actuated position for the second port. So it goes to the second directional control. You actuate it forward. It moves, causes the fluid to flow one direction. When you pull it back, it flows the other direction.
Okay, so what happens to the cylinder?
Which also affects the cylinder. When you pull it back and the flow is flowing the opposite direction, that also affects the load on the cylinder, where it goes back to its resting position when the fluid returns to the tank. You actuate it the other direction.
Which way is which?
Pushing it forward, causing it crisscross, pulling it back is straight up and down, like in the first box.
Backwards.
Backwards, the other direction. You pull it back for it to go straight up and down. Push it forward for crisscross.
You're still backwards. When you push the handle that direction, it moves this way. So your pressure port is connected through to here. Your return port is connected through to the tank,
Correct.
which is going to retract the cylinder.
Yes.
You pull it this way and move this into position. So pressure port is going to be connected to the piston side, and the other port is going to be connected to the tank. So it'll extend.
So backwards.
You guys see that? Yeah. It's exactly the same thing, only it's solenoid operated spring return. So whenever you energize the solenoid, it's going to, it'll retract. No, yeah, it'll retract. Whenever you de-energize solenoid spring, you're going to push it back the other direction and it'll extend. No. Its default is to retract, isn't it? Yeah. Yeah, so when you energize the solenoid, it'll extend. Whenever you release the solenoid, it'll retract. There's a new symbol. A couple of them. Manual drain, turn filter. There's actually a manual valve on the bottom of this that allows you to drain any fluid out of it. Air fin heat exchanger to cool. This is a circuit that is constantly sending cooling water through it. Or in this particular case, I think it's actually a fan. Yeah. So as the fluid is returning to the tank, it's going through the heat exchanger. It's going to try to remove some of the heat out of it, just like the radiator in the car does.
Is the heat exchanger like an electrical power, or is it just?
Well, that particular one is just a fan, so it would be. You could put a hydraulic motor on there and run it off the same power pack that the rest of the system is on too. That would work. Of course, that hydraulic motor would be a source of heat.
It kind of defeats the purpose.
Because it depends on how much heat you're able to remove. Okay, so open center. Every port is open to every other port in the center position. So if every port is open to every other port, every pump, your tank, port A and port B. How's that going to work?
Puts it in neutral.
Okay.
So if it's If it's a cylinder, you could manually move the cylinder, because there'd be no resistance in moving the cylinder up and down.
Sure.
Aside from friction resistance in the line, there's open port
If
for
your
both
pump
sides
is
of the
on,
cylinder for the
then-
tank,
Your pump is on, then all the ports are gonna be connected to the pump too.
in which case it's locked in position, yeah?
Is it?
Don't know.
Matthew, what do you think?
If the pressure, that's from the reservoir, from the pump to the load is equal to each other, then nothing moves. It's locked into that position, it doesn't move at all. When the pressure is the same on both sides.
You sure about that?
You want more pressure than the load to push the load up. And it moves down when there's less pressure than the
What if there's
load.
no load?
But if there's no load at all, then I think that cylinder should be able to move up if there's any pressure from the pump to the
What if the
Cylinder.
cylinder is horizontal instead of up and down?
And the piston face would have more area, the piston would extend if there's equal pressure on both sides.
Assuming that you are restricting back to tank enough to generate pressure. But that's gonna waste a whole bunch of fluid, generate lots and lots of heat because it's not doing anything but idling and dumping a bunch of pressure basically from the pump, through the pump back to the tank, through the pump back to the tank, through the pump back to the tank. So a valve like that would typically be fed by a two-position, two-way. That. For that particular setup, you wouldn't need the two-position valves because you have APV center directional control. For a setup like the open center, the top left there, you would want to have a valve like that in the system so if you're not constantly dumping through that valve back to tank.
So what's the application of an open center? What's the value in having one on the system?
It allows the load to float. The float center, which is the one in the top right there, the pump port is blocked internally in the pump or in the directional control. So you won't need the external normally float valve. But ports A and B are both open to tank, so it allows the load to float.
That is where it's kind of in neutral gear.
The closed center or APD center, everything's blocked. So no pressure, no tank, no A and B. The valve is going to prevent the load from moving at all. It'll lock it in place and won't go anywhere. And then the tandem center where the pump and the tank ports are connected together, A and B are blocked. You would definitely want to feed that with normally closed two position. Otherwise, you're just dumping fluid through the valve. Generate a bunch of heat.
What would be the purpose of a tandem center? Maybe something like,
Well, it's basically the same thing that the closed center does. It prevents the load from moving.
could you put something on the return line? That way, if you're in center farther down the line on the return, you have another system that you want to be always seeing pressure.
then that wouldn't be a tank port.
Gotcha.
Be returned port. That
Gotcha.
would be a tank port.
For the tandem center, you could put in a second, a solenoid control that where it automatically closes the valve for the fluid to go around on the valve where the fluid can go up through the tandem center and back to the tank all the time. Where that's controlled by, you can have a second one to control that,
Yeah.
that flow.
Prevent it. Shut it off. So center positions for three-way, four-way, open center, closed center, tandem center, and float center.
In that case, you would want a second one. You could have like a solenoid control, directional control that shuts everything off.
But
Keep
that's
the
not
fluid
drawn-
from flowing through the
That's
open
not
center all
drawn
the
as part of
time.
the schematic.
It's not in the schematic, but you can add something to control the flow.
You could,
from-
but that particular engineer decided not to do that.
In that case, the fluid can just keep running around through that open center, create a whole bunch of heat.
It's gonna try and put some pressure on the piston side of that cylinder, which may be all it needs to hold that in position. APV center, cylinder doesn't move. So definitely want to be flowing through your pressure relief. And blowing up hoses and things.
On that one,
That one,
on the tandem one, you can add another directional control that where the solenoid can close the shut off,
you
the shut
can't,
off.
They didn't.
But then in that case, it's just gonna keep flowing into the pump, create a whole bunch of heat.
What'd you say, Rick? Float center. In that case, the pump port is blocked, but everybody else is open to the tank. Definitely gonna go through the relief valve. Mounting methods. A subplate mounting method where the directional control valve is mounted to a plate that attaches the system piping, otherwise known as manifold. Inline mounting is a mounting method that uses tubing or threaded pipes that connect directly to the directional control valve. Many pneumatic valves are inline. You're really hard pressed to find a hydraulic valve that is. The hydraulic valves are typically manifolded because they run at much higher pressures. Directional control valve actuator mechanism is used to move the position of the spool, therefore redirect the flow of your fluid. Manual actuator is a type of directional control valve actuator that requires a person for activation. That's the one that has the handle on it. Automated actuator is a type of directional control that can be actuated without a person being involved. So solenoid that will directly move the spool. Piloted It means you give it some kind of a signal on the pilot, and that's what moves the big spool, or spring loaded. Those are the three most common. Spring actuators, when one spring is present, the one on the right hand side, so spring offset. So by our naming convention, what type of valve is that? Andy?
It's spring loaded to positional to port,
Incorrect.
4-port I mean,
Okay.
that's 4 ports.
So port / position. Okay, 4-2.
4-2, spring loaded.
I'm not talking about the top one. 4-2, port position, or 4-port 2 position. What about the bottom one?
4-3, solenoid actuated.
Spring return to center.
The spring return to center.
But you got a spring on both ends. And box with the elongated doodad on it as the manual override. So you can actuate the valve, which been what you guys should have been able to do on your clamp truck. If you had some kind of an override on it, that would at least allowed you to release the pressure off the cylinder.
Right.
So pilot actuators,
It's where a schematic would have come in handy, which we did
Yeah.
not have.
okay, so dash line tells you what?
Pilot.
Solid triangle,
Hydraulic.
hydraulic. So it is a hydraulically piloted directional control. 4-3, spring turn center, APD. All port block center. Solenoid actuators, single solenoid, 2 position, spring return, spring offset. It's going to default to the left-hand side, straight through instead of crisscross.
That one's 4-2.
4-2. The top 2 of them are. One there in the middle is solenoid, both directions, 4-2. On the bottom is dual solenoid, 4-3, APD center, and it's going to spring return to center. So once you understand what the symbols mean, it's pretty easy to figure out what kind of valve it is, right? And it's pretty self-explanatory once you know what you're looking for. That's a new one. D10. Get over. D10 has got this extra little doodad on there. That is actually a spring in there that, as you're actuating it, compresses. It's a roller ball on the top here. As you're moving it back and forth, it's going to press down and click into the next D10. That is a way to mechanically lock a manually operated valve or can be solenoid operated also. But when you move it into position, it will stay in that position until you actuate it in a different direction. Okay, so in that particular case, there are 3 detents. The one in the center is going to lock the valve into the center position, and then of course the one on each end is going to lock it into that position on the either end. But the little rack on there signifies it as detented. Portional actuator is a type of actuator that uses an analog signal to actuate a proportional directional control with a spool that can be placed in an infinite number of positions. That is something of a misnomer because there's no such thing as infinite when you're talking about analog control. But it can essentially be anywhere in the language. Logic valve is a valve that uses pressure signals at its input ports to determine when fluid flow will occur from its output ports. Logic valves are always controlled by pilot pressure. 2 types of logic valves commonly used in hydraulic systems are and shuttle valve, which is an or. It's this way or that way. On an and logic valve, you have to have signal on both input ports to get anything out the output port. Just like an and, you're talking about digital signals. There's an and. Same truth table you see in any other system. Unless both input 1 and input 2 have pressure applied, you don't get anything on the output. Or, did you get pressure on either input 1 or input 2, you get pressure on the output. So, on that shuttle valve, notice that one way it's drawn like a check and the other way is drawn like an open check. That's because that's what it is. Only that check ball is free to move either way. Yep. So if you have pressure applied here, it's going to go that way. Go through to your output. If you have pressure applied here, it's going to go that way. Go through your output. If you have pressure applied on both of them, it may not center. But both sides will be open. So flow can go through either one or both of them and still make it to the output. Matthew?
So in this case, it's a regular or, where it could be either one or both.
Yep. Hydraulic valve safety. Says directional control valves control the motion hydraulic actuators, and special care must be taken when using, troubleshooting, repairing, or replacing. Typically, one of the first components that a technician must inspect when a machine is malfunctioning. If nothing at all works, probably pump or the main system relief. But if an actuator goes in one way, in one direction, not the other, it's directional control. Personnel can be injured and equipment can be damaged if directional control valves are improperly installed or actuated without a technician understanding the potential movements of the controlled equipment. Well, you always want to have a schematic. You can figure out if I operate this valve, what's going to happen.
And not to call you out, Ben, but in his situation, like at work the other day where he couldn't find a schematic, could he have gone to like manufacturer's website and do they have them on there typically, or?
99% of the time, yeah.
Couldn't find it, by the way.
Okay. Probably did anyway.
We did look on manufacturer's website and through about 15 different websites that said they had it and didn't. It's rather a unique model of truck. But we should have the schematic on hand.
That'd be nice.
Yeah, it should have been provided with the truck.
Absolutely. And it probably was, and we just probably don't have it, or it's sitting in a cabinet in some corner of the shop that nobody knows about.
Or in somebody's office.
Yeah, probably behind lock and key.
Mm-hmm.
Yeah. You know how it is.
Yeah, been there, done that. Many times, actually. Worked at a place that they did blow molding, so they made plastic bottles and milk jugs and things like that. And all the machines were German. So all the schematic symbols were IEC. And that was fresh out of college. They didn't teach us anything at all about IEC symbology whenever I was in college. They didn't teach us how to read German either. So figuring out how those worked was interesting. That was before there was such thing as an internet, so I couldn't just look it up. But I did eventually figure out, okay, this does that, that does that, so I redrew all of the schematics and used MEC symbols. Directional control valves must be monitored during normal operation and on troubleshooting system during a malfunction. The way you want to monitor them while it's in normal operation. You gotta have a guess. Why would you want to monitor your directional control during normal operation? Work normally, if it's broke, don't fix it.
PM. Predicted maintenance.
That's typically part of it. There you go.
What do you say?
So you know when it's not working. Right?
Basically, the same thing, preventative maintenance, you know when it works, when it's not doing that.
Gotcha.
Yeah, if I observe it and monitor it while it's working correctly, when it's not working correctly, I can easily go, well, that ain't working like it's supposed to. Matthew?
So basically, as you're monitoring that not normal operation, if something does happen, it just goes back crazy, you'll know why it's doing that, why it's
Well,
misbehaving.
you may not know why, but you know that that ain't right.
You'll know something's not right, but you'll know where to look to figure out why it's going back crazy.
Yep. Well, you know where it's going back crazy, not necessarily why.
But you'll know where it went back crazy if something goes wrong. You'll know where to look
That's where you
when
start.
it goes back crazy.
Where you start your troubleshooting process. Okay, so it normally operates like that, now it's operating like this, or not operating at all. What could be wrong with it? Hey, you know, the valve is not actuating at all, it's only actuating one direction and it's stuck the other way. Why is it stuck the other direction? Is there something caught up in the spool not allowing it to move? Did the spring that's supposed to return the spool break? You know, there's a whole bunch of things that you have to ask yourself. And what are the possible causes for this particular failure? Schematic diagrams from the OEM must be referenced by maintenance technicians when troubleshooting, repairing, and replacing malfunctioning directional control valves, assuming they're available.
If it's not available, you can go and look and see where you can get a copy of it,
You can try.
or try.
In Ben's case, he tried and failed miserably.
After spending a lot of time on it too.
You get paid by the hour or paid by the job?
Hour.
Well, I'd spend all night. Let first shift worry about it. Okay, so correctly installed valve, pressure port blocked, means the valve doesn't move, or the cylinder doesn't move. Incorrectly installed, the pressure port's open, which allows it to go anywhere it wants to. As soon as you apply pressure to the system, the cylinder moves on the right-hand side. Left-hand side, they're definitely better.
Yes.
For a motor application.
If you connect A and B ports together, allow them to return the tank, block off the pressure port. Not gonna take long for that motor to stop. Do an APB center, as soon as you return it to the center position, it's going to basically come to a screeching halt really, really quickly.
Same guy here is complaining too, or it's
Oh, yeah.
squealing.
Things will go banging and clanging and.
Okay, you definitely know that you need a different valve at that point.
Yeah.
You know something's not right, if you're acting out, right, just going back crazy.
Yeah, that's a good way to break things on the right-hand side.
Is that used in emergency stop situations? Or is it usually?
Depends on what you're doing. By definition, emergency stop is all motion stops. But it depends on what is the lesser of two evils. You know, if I need to stop it immediately right now, then I'm going to use the one on the left or on the right-hand side. If I need to stop it within, you know, a couple of seconds versus right now, I'm probably going to use the one on the left-hand side and then put an external brake on it that I can engage. Matthew?
You could put in a solenoid control, to position directional control underneath for the emergency stop when it needs to actually stop it. Instead of just always, just completely stops abruptly, causing equipment damage in the case of the ride.
That would work. But if I can do it with one valve, why would I want to do two? I have two valves in there, I've got 2 points of failure. I only have one valve in there, I've got 1 point of failure.
So I don't really need one for the default one.
you don't necessarily want one. Review and activities, yay. So, I realize this is the epitome of foolishness, but questions?